In this video, we are going to learn how to predict the outcome of a variable. We can analyze the data further by finding an equation for the straight line that best describes the pattern. This equation can be used to predict the value of the variable designated as the response variable from the value of the variable defined as the explanatory variable. This is called the regression line or prediction equation. This is how regression line or say prediction equation may look like in simple linear regression. This notation is called y hat. Hat is for this simple. Y hat is the predicted value of y. X is the explanatory variable. A here is called y-intercept. B is called slope, which is the angle between regression line and this horizontal line. Pay attention that this graphic is for A larger than 0, B larger than 0. If your intercept or slope is negative, your regression line will look different. Remember that the equation of a straight line is y equal m times x plus b. The regression line or prediction equation is the same formula by different notation. Regression line or prediction equation will be provided in the StatQuant output. We use same commands as we did in last video. Y-intercept is the predicted value of y when x equals 0. Not all scatter plots have a value of x equals 0, or even a value of x close to 0. We can interpret the y-intercept in the equation using the following outline. The predicted value of y will be the y-intercept when x is 0. Please see examples for clarification on this. Slope is the amount of y hat changes as x increases by 1 unit. When the slope is negative, the predicted value decreases as x increases. The line goes downwards. The association is negative. When the slope is positive, the predicted value increases as x increases. The line goes upward. The association is positive. We can interpret the slope in the equation using the following outline. For every 1 unit increase in x, the predicted value of y will increase or decrease by the union of the slope. Please see examples for clarification on this. This is a screenshot of a StatQuant output. In last video, I have shown you how to reproduce the result on the left. Please try to reproduce the result on the right. If you have difficulty, please email me. After we get the StatQuant result, we can get the prediction line. Number of points is y hat. This number here is intercept. This number is slope times total offense. total offense is also x. Slope is 0.10. As total offense increases by 1 unit, the particular number of points scored by USC will increase by 0.10 points. Y-intercept equals negative 15.61. This means the particular number of points scored by USC will be negative 15.61 if the total offense is 0 yards. The prediction of x equals 500 can be calculated in this way. Y hat equals negative 15.61 plus 0.1 times 500, which equals 34.39. This means if USC have total offense of 500 yards, the estimated points USC got is 34.39. This is the StatCrunch output for a simple linear regression between number of pounds and total offense. Number of pounds is Y hat. This number is called Y-intercept. This is slope. Slope is approximately 2, negative 0.02. As total offense increases by 1 unit, the particular number of pounds made by USC will decrease by 0.02. The Y-intercept equals 11.40. This means the predicted number of pounds made by USC will be 11.40 if the total offense is 0 yards. Prediction at total offense of 500 yards. The Y hat equals 11.40 minus 0.02 times 500 yards. This equals 1.4. This means if USC has total offense of 500 yards, the estimated number of pounds will be 1.4. That's one thing you have to pay attention to. Extrapolation is dangerous. Extrapolation refers to using a regression line to predict Y values for X values outside the observed range of data. If the trend changes, we get a poor prediction. You can only use the prediction model for values of X that were used to create output. Use the following scatter plots to determine if there is a relationship between those values. For example, you can only plug in values of X from 218 to 588. 218 is the minimum value. 588 is the maximum value. It means the minimum value and the maximum value we recorded or we observed during USC games. Residuals is another important concept. We can compare predicted values to the actual values to check the accuracy of the prediction. The prediction errors are called the residuals. On a scatter plot, the vertical distance between the point and the regression line is the absolute value of the residual. It is denoted as the difference y minus y hat between the actual and the predicted value of the response variable. Each observation has a residual. The blue line here is visualized residual. Black dot here is actual data point. Red line here is called prediction line. In this example, I will show you how to calculate residual. Let's make a prediction of x equals 481. In other words, total offense of 481 yards. The y hat equals negative 15.61 plus 0.1 times 481. This equals 32.49. The residual is calculated as the actual points USC scored minus the predicted y or predicted points USC scored. Difference between these two numbers is residual. 6.51 here is residual. This means the total points for the South Florida game is greater than its predicted value by 6.51 points. Let's make a prediction of the number of punts. The prediction at x equals 481 should be calculated as 11.40 subtract 0.02 times 481. The residual is calculated as the actual punts USC scored. Subtract the estimated number of punts. The difference between 2 and 1.878 is the residual. This means the total punts for the South Florida game is greater than its predicted value by 0.22 punts.